Well, welcome back to the 11th and final module in our Querying Transact SQL course. In this module, we're going to build on all the things that we've talked about up to here, and we'll deal with one final really critical part of building solutions with Transact SQL, and that is handling any errors that might occur and using transactions to ensure the consistency of data that we're working with in the database. So it's a critical part of any Transact SQL solution, and this will really kind of round off everything that we've talked about in the previous modules. So we're going to talk about a number of different things in this module. We're going to talk about errors and error messages. So either something goes wrong in the system itself and an error occurs, and we'll see the error and error message, or you yourself have some logic that you've determined a condition has arisen that you want to throw an error for. So we'll look at how we handle that. We'll look at how we raise those errors. We'll look at catching and handling errors in your Transact SQL code so that you can recover from an error situation and get the database to a state that you're happy with, even in the event of something going wrong. And then related to that, we'll talk about transactions, where I might want to do updates or inserts to multiple tables or make changes that I want to remain consistent across multiple operations. And I'll use transactions to ensure that either everything I'm doing succeeds or it all gets rolled back and cancelled in the event that something goes wrong. So let's dive on and have a look, first of all, at errors and error messages. And then Jeff, I know you've worked with a lot of different database solutions in the past. It's a critical thing, really, isn't it, being able to handle errors?
Yes, and I think you brought up a good point in the introduction, that saying you can raise these yourself. This isn't my hard disk has failed necessarily. This is, I would like to raise an error because of a condition. So we're not just saying there's been a system error.
It could be some business logic that says, well, that's a perfectly legal thing to do in terms of what's in the database, but my business logic determines that you can't have a price greater than 100 or something like that. Yes. I want to throw an error.
And it can even be just informational. It can be a very low level message.
Yeah, and that's an interesting point as well, that when we see error, we assume something's gone catastrophically wrong and there's an error message. An error might just be, I want to pass back some sort of informational message to the client to say, yeah, you did this update, actually it succeeded, but it didn't affect any rows. It's not really an error, but it's some information I might want to pass back to the client application and let the client application deal with that. Yep. So when we're talking about errors, we kind of have to understand what errors actually are. And really they consist of a number of different kind of attributes, a number of attributes of an error. It's a situation that arises, the system or your own code will flag up an error, throw an error is the terminology we use. And an error consists of some sort of unique number that identifies that error. Like everything else in databases, we have unique identifiers, and errors have a number that identify the error. And then there's usually a message that goes along with that, some text that describes, what is the error, what's the problem, what's the message we want to send back. So those two things are fairly kind of obvious, and I guess at the very minimum, those are the things you would deal with when handling errors. But there are some other aspects of errors that are interesting. So we got on the list here, severity. So Jeff, tell me a little bit about that.
Well, the low-level severities, we were saying we could just be a message. So we want to notify the client of something. And that's typically your low-level severities. 1 to 10 are just informational messages. And then when we start to get to higher numbers, they become that there is actually a problem. We have something has gone wrong in here. We're saying it's a higher severity. And when you get to the very highest, up in the 20s, then actually that's catastrophic errors. That kills the connection to the server. That's bad things have happened error. So we want to be able to distinguish between, because they are, as well as errors, they can just be messages, they can be informational. We need to be able to distinguish those levels, really that sort of 3 levels that we have of error in there. So when you throw a message, it's not going to be the very highest one. We've got to mention that not in a SQL, Azure SQL database assist messages, but in SQL Server we can create a message, and you can define some of those portions of it and say, okay, I'd like it to be at this level. And then we can test for that as well and say, well, let's have a condition to say what is the severity of that value, and based on that, perform different things.
Yeah, and I guess it's worth pointing out as well, when we throw our own errors, as you say, in SQL Server, we can add messages to sys messages, and we'll talk about that in a second. But even the errors that you don't raise, the system errors that get thrown, will have a severity that's predefined. And if an error is thrown that has a critical level of severity, SQL Server itself will do certain things in order to cope with that. So as you said, if it's a really high severity message, SQL Server will automatically close the connection and perhaps take the database offline or whatever it needs to do. So if the disk becomes corrupt or if something major happens to the system, SQL Server will throw an error, and then it will take some sort of action to mitigate that error. But what you might want to do is have any code that you've got running at the time to catch the error and log it, so that later on you know what went wrong and you get an idea of what was happening there.
And some of these you'll have seen if you do the labs that some of them have intentional failures in there for a reason. And we say, oh no, we should have coded it that way. And you'll see all this information because it will be thrown out by the system.
That's right, yeah. You'll see it in the UI, yeah.
All that information in there, a number message, line number is all listed in there.
So as well as the severity, the other thing that you have is a state. And state isn't really anything to do with how severe the error is. It's a code that's used to indicate what the SQL Server operating system, rather than the Windows operating system, what the SQL Server system was doing at the time. And it's primarily something that you would use if you went to your support representative who was supporting your database. You came to Microsoft support to get help with something that was happening. They would look at that state and use it to diagnose what was going on in the system at the time and use that to figure things out. So it's really for kind of after the fact troubleshooting. There's another couple of things that get thrown out as well. The procedure, if you've written stored procedures, as we covered in the last module, and while that stored procedure is running, an error occurs, one of the things that will be part of the error that gets raised is the name of the procedure. So we know which stored procedure was running when the error occurred. And if you've got a stored procedure that calls another stored procedure that calls another stored procedure, you can use that to track down where the error occurred. And then to help you get even more accurate information about where it occurred, there's the line number within that stored procedure where the error actually occurred. So you can get right to the individual statement of Transact SQL that ran and presumably caused the error, or at least it was running when the error occurred. So I mentioned, just before we move off this slide, we mentioned the sys messages table, and this is another one of those areas where we're certainly, at the moment, at the time we're recording this, there's a difference between SQL Server and Azure SQL Database. In SQL Server, and historically over lots of versions of SQL Server, it's been like this, certainly as far as I can remember, there's a system table called sys messages, and that's where all of the system error messages are stored. SQL Server actually uses a table in the database to store the different messages that it can throw. And when it's ready to throw a message, it throws the relevant message from that database table. Now you can, in SQL Server yourself, add your own user-defined errors to that table. And there's a system store procedure called SP_add_message that you can use to go ahead and add your own custom error. And that error could include a custom severity level, a custom message, all the kind of attributes that you would have of a system error. And then if you have code that wants to throw that error or raise that error, you can simply throw it by specifying its message number, and all the rest of the information is got out of the sys messages table and thrown. And it's a technique that has been used in a lot of databases over the years in SQL Server. It's not necessarily one that I would use now going forward, because we have a new piece of syntax that we use to throw errors, and we're trying to get away from the idea of user-defined messages having different severity levels, because that affects how the system behaves and can actually make it a bit unpredictable. So you can use that technique. You may be maintaining a lot of code that already uses that technique, and it's good to be aware of that. But also be aware that if you are migrating to Azure SQL Database and you're doing some code there is no sys messages table there that you can access, and you haven't got the ability to create your own messages and store them permanently. Rather, what you do is throw the error messages as and when you need to throw them from your line of code.
Yeah. If you do create them, one thing I would say that can be useful, the message you have can have parameters within it. So we don't have to say, oh, well, we need one message for product table, we need another message for the sale table, we need another message. We can pass, let's say, that the name of that table into the message that we've got. So we can create a message which has parameters, and they can be numbers, they can be strings, and we can pass values into there. So you can have a message which is a bit more variable.
Yeah, yeah. And of course, if you wanted to use that technique, there's nothing to stop you creating your own sys messages table for your own user-defined error messages and effectively using the same technique. I do want to talk about raising errors or throwing errors as the terminology might have it. And let's start with raise error. And this is the command that's been in SQL Server for many, many versions. And it's how you raise an error that's in the sys messages table or just an ad hoc explicit error. So in SQL Server, like I said, you can use this to raise error and then just give it the ID of the error, the number, and it will go and look up that error in the sys messages table and raise that error. That technique only works in SQL Server. You can't use that in Azure SQL Database because, as we said before, you don't have the sys messages table. What you can also do, though, is you can use raise error, and this is true in both SQL Server and Azure SQL Database. You can use raise error to raise a custom error at this point. You're going to define it as part of the raise error statement. And in the example on the slide, you can see raise error. We've then just specified what's the error message we want to raise. An error occurred. It will be assigned the value, I believe it's 50,001 is the error message.
Yeah, you're not allowed to use anything 50,000 or below.
That's right, yeah. So you can't specify, when you create your own custom error numbers, they can't be less than 50,000. And I believe it may be 50,000 or 50,001. We'll actually see in the demo. But it'll raise the error with that error message, and I can specify the severity and I can specify the state when I do that. So in this case, I've set a severity of 16 and a state of 0. Well, that, as I said, that syntax has been around for a while, and a few versions ago, some new syntax was introduced as a slightly better, more consistent with other applications way of handling errors, and that's the throw command. When you're programming in other environments than SQL Server, we typically talk about throwing errors rather than raising errors. So we have this idea of the throw command. You can think of this as the replacement for raise error. Raise error is still there, and it's still available in SQL Server and Azure SQL Database. But going forward, you're probably better to use the throw syntax to throw custom errors. And it lets me throw an explicit error number. I can specify the number of error I want to throw, a message, and a state. And again, we mentioned about the error number has to be above 50,000. I can specify any message, and I can specify a state that I want to use for troubleshooting later on. Notice that I can't specify the severity. The severity is always 16 if I throw a user-defined error.
So we can't throw a really high level.
You can't just in your own code suddenly define a really high level that's going to bring the system down, and that's why it's so that SQL Server itself will handle those critical system level severity levels and deal with them in its own way. But we don't want you confusing things by throwing critical errors that are going to bring the entire system down. So the severity is always 16.
And the state, you said you could investigate that afterwards. So I could just use that for my own purposes and say, well, if I'm throwing a 1, I mean one thing. If I'm throwing a 2, it's actually... So when I investigate afterwards, like I say, if that's 2, I know what happened is
yes,
you had a problem with this particular stored procedure or whatever. I know some more information because of that value being passed.
It's a way for me to add some sort of diagnostic indicator that means something to me as the developer.
But without it popping up obviously to the person with the client saying...
Yes.
With a different message.
Exactly, yes. So one of the things we can do, we can do this throw and a custom error number above 50,000 and a custom message and state. The other thing I can do is if an error occurs that I'm not expecting, we'll see in a minute how to catch that error, and what I can then do is just simply rethrow the error that happened. And you might think, well, why would I do that? What's the point in that? Well, I might catch an error in order to log it and do any cleanup that I think is necessary, but then I still want to throw the error so that the client application handles the error. So I'm doing what database level cleanup I can do, but then throwing the error back so that the next layer out, the client that made the call to the database can actually catch the error and do whatever error handling it has to do as well.
So that catch is essentially intercepting.
Yeah, I'm intercepting the error. I might handle the error completely and deal with it, or I might just do whatever cleanup I can do and then throw the same error again.
Because they're not going to see the original one because it had been caught.
Yeah, exactly, yeah. So in this demonstration, we'll have a look at seeing how we can throw errors, how we can raise errors. So I've got, in this example here, just a regular insert statement here where I'm inserting into a table some values. And I'm going to go ahead and run that code. And I immediately get an error. I can see in the user interface in SQL Server Management Studio it's an error because I get this bright red text at the bottom that tells me. And I can see the message number, that's the error number there, which I've just clicked away from. The level, the severity level, the state, the line on which it occurred. There's no procedure because, of course, this isn't in a stored procedure, but I can see that it's line 2 of this set of script here because the first line has the comment on it. And I can see what the error message is. It's the insert statement conflicted with the foreign key constraint, which has a really confusing name. The conflict occurred in the database AdventureWorks LT, and the table was sales order header, the column was sales order ID. And this is an example of what Jeff mentioned earlier on when we were looking at the slides, that these error messages may be parameterized. That same generic error number 547 will be thrown any time you try to insert into a table that has a foreign key and there isn't a matching primary key in the other table, which is what this means. But we parameterize the name of the table and the name of the column and even the name of the database, so that is customizing the message, if you like. So that's an error that's been raised by SQL Server itself. It's not, I didn't write any code to throw that error. SQL Server threw it automatically because I tried to insert a row into the sales order detail table and there isn't a matching sales order to go with that sales order detail. Well, what if I try to do something that is perfectly legitimate in terms of Transact SQL? It isn't going to break any constraints or change any data consistency, but my business rules are such that I want to mark that as an error and do something about it. Well, we've looked at row count in a couple of the previous modules. We've talked about the row count when you update tables or insert tables, and we previously saw how to use an if statement to check on the value of row count and print a different message depending on how many rows were affected. And what I might want to do is I might want to say, well, if I have a statement that doesn't manage to affect any rows, that's probably not what I intended.
But that's not an error, though.
It's not an error.
Not doing anything isn't an error.
Yeah, nothing has failed, but I do want to throw a message to the client to say, hey, you tried to do this statement and it didn't actually succeed in any rows. It's then up to the client to decide whether it wants to handle that error and continue or whether it wants to do something about it. But I'm effectively just throwing the error to the client so that it knows something anomalous happened. So if I go in and run all of that code, I'm updating the product table, I'm setting the discontinued date to today's date, where product ID equals 0. Now I know for a fact there aren't any products with the ID 0, so I'm checking after I've done that, if the row count is less than 1, then I'm going to use raise error to go ahead and throw that error. So I'm raising an error with this message here, the product was not found, the products have been updated, severity level 16, state 0. So I'll go ahead and run that. And you'll see, yes, it returns 50,000 as the default error number. I didn't specify an error number, but because I used raise error to raise a custom error message, it automatically gets assigned that number and it passes out my message. Now, I mentioned in the slides that raise error has been there for a while and it's kind of been superseded by the throw statement. So here's an example of exactly the same scenario, but this time I'm going to use throw if no rows are affected, and I'm throwing specifically a message number. It has to be more than 50,000, so I'm throwing 50,001. And I can use whatever numbers I want to use, and I might, again, for troubleshooting purposes, I might categorize my errors, and I might create a table that stores them and so that I know which ones means which. And I'm passing the same error message with a state of 0. I'm not specifying the severity, because I can't do that with throw. But it comes back with a severity level of 16. And I get the information about what's been thrown. Note it automatically picks up the line number as well, that comes out there as well. So we've seen a couple of examples there. First of all, that SQL Server itself might throw errors. And secondly, in my own code, I can use raise error, or more commonly going forward, I can use throw to throw an error. And
that just protects you. You can't do anything too bad with the throw. You're not allowed to elevate your severity up to at
Yeah.
a reasonably high level.
Yeah, the idea is to try and avoid writing your own Transact SQL code that ultimately could bring the server down because you've raised a really critical error. If there is a really critical error that means SQL Server has to stop, SQL Server itself will spot that and it will deal with that.
Yep.
So we've talked about throwing errors. We mentioned catching errors a little bit. Let's look in more detail at what's involved in catching and handling our errors. And the first thing is, in common with a lot of programming languages, some of which you might already be using, we use this technique. The technique is generally called structured exception handling. And what we're really doing is we have a try block of the code that we want to run, the code that does what we want to do. But then we have a catch block, so that in the event something failed in what we were trying, we then catch the error that happened and we handle that error. And we either deal with the error and fix it, or we log the error, we recognize that something went wrong, and we clean up as best we can and possibly throw an error to the client application that called this so that it can then deal with that error.
So if nothing goes wrong in there, the try, does it just behave normally, or does it...
Yeah, if nothing goes wrong, all the code in the try block gets executed and the catch never runs. The catch only runs if an exception occurs. Yeah? So we have this try-catch block. It is worth mentioning you can handle errors in line, and that's a technique that a lot of people who grew up on kind of basic programming might be used to. The idea of just after every time you do something that might cause an error, you check to see if it caused an error, and then you deal with it. You can do that. You can check there's a global error number that you can check for, a global variable called error number you can check for. But really, we try and advise people, don't try and do that. It leads to really messy code that you can't troubleshoot easily. Much better to use this structured exception handling approach with a try and a catch block. If you have used try and catch in other languages like C#, there is no finally block. There is no additional thing that I can run in the event of whatever happens. It's just try and catch in Transact SQL. In that catch block, that's where I'm going to actually handle the error that occurs. And of course, one of the things I might want to do is actually interrogate the error and find out about what happened. So there's a number of system global variables and functions that I can use. And I can do things like look at find out what error number occurred. I can find out all the different bits of the error, so the message, the state, the severity. I can get all of that. And I can write some fairly sophisticated logic in my catch block that, depending on the error, the number, the state, or whatever, does something different. So I might catch an error, and if I know the severity level is 16 or less, then I might tidy it up, log it, and then try and continue. If the severity level is higher than that, I might throw an error to the client. I might do some additional detailed logging or some other thing like that.
I've seen ones where people using that information, the ATAT error, and quite often they end up writing another line of code though. And so what happens? Then they go, well, there doesn't seem to have been an error anymore. Yeah,
that's a good point. Once you've read the ATAT error, if you then execute a line of code, in fact, even executing the line of code that reads the ATAT error, means that there's now no longer an outstanding error in the system because the last piece of code that was executed ran successfully. It was the piece of code that checked the error number.
So we really need to put it somewhere.
Yeah, you need to catch it and put it somewhere in the first place, into a variable or something like that. The techniques that you can use, like I say, you could write really sophisticated code in your catch block, and really it's entirely in your hands what you want to write. But a couple of fairly common techniques are to either catch it, write some code that corrects the issue if you can figure out what the issue is, or at least log what's happened. And then typically you either rethrow the original error so that a client application can then catch it and do its own error handling, or you log the original error and you throw your own custom error to the client that effectively says, look, an error occurred, but I handled it, I logged it, and go and check the log file to find out details about what happened. So you will find this idea of a chain of exceptions, and when people are troubleshooting applications and looking at error logs, they quite often talk about the exception hierarchy. You have exceptions within exceptions within exceptions, and in this case we're catching one exception. We can either rethrow the same thing, or we can catch the error and throw our own error out again. So let's look at a demo where we're going to deal with catching errors and handling them. And I'm going to start with this fairly simple example here. you can see I've got the begin try block. So there's the try block, begin try and end try. And what I'm going to do is I'm going to update the product table. I'm going to set the product number to the product ID divided by the weight. And if the weight is null, I'm going to use 0 for the value of the weight. And that might immediately trigger some alarms.
Yeah, you seem to be dividing by 0.
I seem to be...
infinity.
If I've got any null weights in there, what I will end up doing is trying to divide by 0, which actually you can't do. So in the event that something goes wrong, then my catch block will execute. And all I'm going to do in my catch block in this case is simply print that an error occurred, and I'll print the error message, the outstanding error message of what went wrong. So let's actually go ahead and try that. And sure enough, I don't get red text because at this point there now is no error. My catch block handled the error, so the system hasn't thrown an error, but my catch block, my error handler, actually gave me that print message. It said the following error occurred, and then it printed out whatever the error message was, and the error message was divide by 0 error encountered. So in this case, from the calling applications perspective, and of course in this example the calling application is SQL Server Management Studio, SQL Server Management Studio doesn't indicate that there's an error, because as far as it's concerned there isn't. The error has been captured by my code, but my code has caught the error and handled it. Well, that's one way of doing it, but what might be useful is to handle it, but then also rethrow the error so that the client application does know that there's an error and it can do its own error handling. So in this case, exactly the same try block. In the catch block this time, I'm printing the same message that I printed before, but then I'm throwing, and I'm just saying throw. I haven't specified a number or a message or anything like that. I'm just saying throw, which means throw the currently outstanding error.
So that's that rethrow that you were talking about.
Exactly, yeah. So it isn't a rethrow keyword, it's still the throw keyword, but without any parameters, which basically says, the error that I've caught, I want you to throw it now. Just pass it on to the client application that called me. So if I go ahead and run that code, I get my error handler running, so it deals with the original error and it writes down the message, and that's all. You'll notice that's not in red because at that point there wasn't an error. But then it throws the error again, and this time the error gets caught by SQL Server Management Studio, which responds with its error handling code. And in SQL Server Management Studio, when it encounters an error, what it does is it displays red text with the error details.
So there's a difference between those two things. The first one is just a message.
Yes.
It's not actually an error. It may have error text in it, but it's not technically an error. And the second one...
It's more insidious than that. There are two errors going on here. But the first error has been handled by my code, and the way it handled it was to write a message. And then the second time, once I rethrew the error, the SQL Server Management Studio caught the error and it handled it in the way that it handles errors, which happens to be to write out the error message, but this time in red.
And the client only saw that second one.
The client application only saw the second one. The first one was handled by my own code, my own Transact SQL code. So there is a kind of further sort of advanced way that we could deal with this. So let's have a look at a slightly more interesting example. And this time, what I'm going to do is I'm going to have the same try block. So I'm effectively just triggering the same error. But what I'm going to do this time in the catch block is I'm going to create myself a couple of variables. I've got an error log ID as an integer, and I've got an error message variable. I'm going to call a store procedure. There's a store procedure here called, it's in the DBO schema, called USP log error.
And that's in just the Azure sample database that we're using?
That's in the Azure sample database. It's been created as part of that database. And I can actually go and see that store procedure. If I go into programmability and store procedures, I can see there's a DBO USP log error. And I can even actually generate the code that's used. Remember, we used SP help text in one of the previous demos to do this. I can actually do the same thing with the user interface and generate the code that's used to create that stored procedure. It's quite a long and complex stored procedure, so I'm not going to go into the details too much. But effectively what it does is it catches it, it logs it into a local table. I have a table here called dbo.errorlog. It logs the error into that. We'll actually see it do the insert into that error log table. So it will log the error in there. And then it will get the identity. Remember, we talked about retrieving the identity value in some previous modules. Gets the identity of the error that it's just entered into the error log. So it's not the error number, it's the number in the error log. And then it will throw that back as an output parameter. It returns that as an output parameter to the stored procedure.
So we could then go and have a look at.
We can then go and look in the error log to see what happened, yeah.
So this putting error code and a quite complex way of dealing with errors, putting that inside a stored procedure, is that to try and make it more reusable, or?
Yeah, it makes it more reusable and encapsulates all that logic. I wouldn't want all that logic in every single error handler that I write in Transact SQL.
Because it would have to be in every single catch block. Would have to have that.
Exactly.
And if everything has try catch blocks, then
yeah. So I write it once, I put it in a stored procedure, and then every time I've got a catch block, if I want to log the error, I just call that stored procedure to log the error. So here I've got my my call here, my execute or exec I could have to my stored procedure, and you'll notice that I've got the error log parameter, and specifically that's an output parameter because I want to get that number back. When that comes back, I've called the stored procedure, I've logged the error, I've got the ID of the error in the log file. What I then do is I set my error message variable, and there's a number of things I've got in here. First of all, the update failed due to, because of an error, view error number, and then I'm taking that output value that I got from the stored procedure, so I know what number that is in the table. I'm having to convert that to a varchar because obviously this is a message, it's a string. And then I finish off the message in the error log for details. And then I'm throwing a custom error. And the custom error is number 50001, this message that I've just created with a state of 0. So we actually see how that kind of hangs together. Let's go ahead and try it. And I get my error message, we can see it down here. And what's happened here is the error has occurred. The error was a divide by 0 error. That's not the message I've thrown. I've caught that, I've handled that by logging it, and then I've generated my own error to pass back to the client application to say, look, an error occurred, but I handled it and logged it. If you want to see the details of it, then go and look at error, in this case, error number 1 in the error log, because up till now all my code's been perfect and I haven't caused any errors. So that means that I could now, as part of my troubleshooting, say, well, my application got this error. Obviously something happened at the database level. The stored procedure in the database handled the error, but it's logged it. I'm going to go and see what the problem was. And if I then go and look in the error log table, I can actually see the error log, the time it happened, various other bits of information, the error number, the severity, the error state. In this case, it wasn't in a stored procedure because I just did it in the script file here. But there's the error message of the original error that occurred that I caught and handled. Now, handling errors is one thing, and we've seen how to throw errors and how to catch them and handle them. But what we have to think about in the context of a database is, how do I protect the integrity of the data in the database? And just handling exceptions doesn't necessarily mean that that's going to protect that integrity. To do that, to protect the integrity of my data, I need to think about things in terms of transactions. So a transaction is a group of tasks that together form a single unit of work. So up till now, we've been executing update statements or insert statements kind of one at a time. We've updated one table, then we've updated another table. But what if a logical unit of work involves updating 2 tables or inserting into 2 tables? And I can't have it partially succeed or partially fail. All of it has to work together. So we have in the past quite often talked about transactions as being ACID transactions. If you think of the word ACID as an acrostic for the transaction being atomic, it's one unit of work that everything contributes towards. You can't split it up into separate things. It's all one thing. It's consistent. So when the transaction finishes, the database will be left in a consistent state. There won't be any orphan rows in one table that have missing rows in another table. It's isolated. So while that transaction is actually happening, it doesn't affect the operations of other ongoing operations in the database. If other queries are querying tables, they don't get to see data that I've half inserted or something like that. And it's durable. Once the transaction is finished and I'm sure that I've done all the bits of work that I need to do, then it's persisted to the database permanently. It won't then get deleted unless I explicitly delete it. So if you see people talk about ACID transactions, that's what they're talking about. The point is, it's a single atomic unit of work where everything must succeed or all of it must fail. I can't have a partial success. So thinking about the example on the slide, imagine I want to insert an order. So customers on the website, they've placed an order and I want to insert that order into the database. Well, the order might consist of an order header, which has the date and the customer ID and the order number and all that type of stuff. But then that order might consist of multiple line items. They might order a bike and a helmet and gloves and a whole bunch of different line items. So I actually have to insert into two tables here. I have to insert in the order header table, and then I have to insert the corresponding order details into the order detail table. What I don't want is a situation where I insert the order header, but then don't manage to insert all of the order details that go with that. I don't want to lose any of the order details. If something goes wrong while I'm in the process of doing that, I want to not insert any of it. I want to roll it back. And the other example that's commonly used is if you imagine a transferring funds from one account to another.
The idealistic banking scenario that
Indeed, yeah.
instantly moves money from one account to another.
Instantly moving money from one account to another. You don't want a situation, if you're the customer, you don't want a situation where the bank debits the money out of one account and doesn't credit it into the other. And if you're the bank, you certainly don't want a situation where you credit the money into one account but then don't debit it out of the other. So both of those operations have to succeed, or both of them have to fail. So in SQL Server and Azure SQL Database and Transact SQL generally, if you do an insert statement or an update statement or a delete statement, as we've seen in previous modules, it might affect multiple rows, just that one statement. And you might be wondering at this point, well, how do I make sure that it doesn't just affect some of the rows and not all of the rows? How do I make that a transaction? Well, the answer is you don't have to, because any individual Transact SQL statement that gets executed, SQL Server itself treats that as a transaction.
So if it falls over halfway through the rows, it will never just do half the rows. What even if the server stopped halfway through the rows? What happens when it restarts then? Presumably then it's done half the rows.
No, if the server stops, if you do an insert statement that inserts, let's say, 10,000 rows, 5,000 of them have been inserted and somebody pulls the plug out and the SQL Server itself goes down, when it comes back up, the way that SQL Server works is it has a write-ahead transaction log. It logs all the things it's going to do. And only when it's finished does it write that it's finished. It writes that it's committed that transaction and that's been what they call checkpointed. What it will do is when it comes back up again, it will read the log, and if it finds something where it started to do something but then never checkpointed it, never finished it, it will roll it back. So it will make sure that we finish with a consistent database where either all of the transactions succeeded or they failed. And in the case of an individual statement, there's nothing special you need to do in your Transact SQL code. An individual insert statement or an update statement or a delete statement is in itself a transaction, and SQL Server will look after the consistency of that. However, if you've got multiple statements that you want to execute, then you have to explicitly make that transaction, and we'll look at that in a few seconds. So we've got this notion of SQL Server using the transaction log to support transactions. The other thing it uses, we talked about transactions being isolated, so you don't impact other users at the same time. And SQL Server uses a mechanism of locking. It locks the data pages so that other operations, other concurrent sessions can't read the data or write to the data while your transaction is in the middle of modifying it. And it's a very complex topic. There are lots of different ways that you can handle locking and handle different levels of isolation. And if you are interested in that, we have other courses available that you can come on and learn how to manage those different isolation levels and handle the locking. For now, all you really need to be aware of is that SQL Server is using those techniques to ensure that each individual statement is a transaction, and if you create your own explicit transactions, then it will also use the same techniques to manage those. So speaking of explicit transactions then, how do we implement them? Let's have a look at that. So the way that we do this is there's a number of statements in Transact SQL. The first one is the begin transaction statement. You can say begin tran as well, like a lot of things. There's optional ways to do it, but it's begin transaction is the full syntax. And if I do a begin transaction, then everything from that point on until I either commit the transaction or the transaction fails and is rolled back is considered atomic. It's considered a transaction. So I've got in my code here, I've got begin transaction, and then I'm going to insert into the sales order table and insert into the sales order detail table. That's the atomic unit of work I want to complete. Both of those things have to complete as one transaction.
And you've put that inside a try block, so you're combining what.
Yes, yeah. I'm still. This doesn't prevent me from having to handle errors. I still want to handle errors. It's just I'm encapsulating those statements to be a single logical unit of work, even though there's multiple statements. So once I've done everything I need to do within that try block, I've managed to do the insert into order. I've done the insert to order detail. Nothing's gone wrong. The sun is in the sky. Happy days. Everything's fine. I can commit the transaction at that point, and SQL Server will, at that point in the log, say this transaction is committed, so it knows that that complete atomic unit of work has been performed successfully. If, however, while I'm in the process of doing the insert, an error occurs, at that point, my error handler will catch the error, and I can, in that error handler, start to look at what's going on with the transaction. So in this case, you can see I've checked the tran count. Now that's odd, because that implies that I could have multiple transactions going on, which in fact is true.
So these other transactions from other people? Or?
No, these would typically be transactions where I've done a begin transaction, and then within that I've begun another transaction. So I could have a transaction that's inside a transaction that's inside a transaction. They could be nested.
So if you had to say you called a stored procedure and in itself it had a transaction within it, then you have a nested transaction within there.
Exactly, yeah. Now what's interesting here is I'm dealing with the issue by doing a rollback. And if I roll back, I don't just roll back this transaction. I roll back all the transactions all the way up the.
So whatever happens, you can't just roll back the bit that in there. It's basically going to roll back all the calling ones as well. So you're going all the way back to the beginning.
Yeah, because I want the whole thing to be consistent. I want it to be atomic and consistent. Yeah. So I've got that rollback statement in there. You'll notice I've checked the tran count to see how many transactions are going. There are a few other ways of interrogating transactions that we'll talk about in a second. The other thing is I've explicitly rolled back the transaction here. So I can write the logic that checks to see, do I actually want to roll back the transaction? So all is not lost at this point. If I get to this point, and what's happened is I've done the successful insert into the sales order, and I've done the successful insert into the sales order detail, and then perhaps there's been another bit of code that's triggered an error, but that hasn't really affected the transaction. I can check down here on the state of the transaction and choose whether to call rollback transaction or not. One of the alternative techniques I can have is I can set this option called exact abort. And if I set that on, then as soon as an error occurs, all transactions are automatically rolled back.
So any error, you can say
Indeed.
Specify an error or just anything? And it's
in that case, any error occurs, then everything's rolled back. So in some ways, it makes life easier because I don't have to do all the code that checks, and I don't have to explicitly call rollback transaction. But in other ways, it's kind of an all or nothing deal. If anything goes wrong anywhere at all, regardless of whether it affected the integrity of the data or not, I'm going to roll back the transaction. Yeah. So the other thing I talked about there was we looked at tran count. We checked the number of transactions going on. There is another system function that I can use called exact state that lets me go and check the transactional state. And it passes back various values. A 0 means currently there aren't any transactions in process, so I can carry on regardless. A 1 means, I think I'm getting this right, a 1 means a transaction is in process, but it's at a point where it could be committed successfully. So there's nothing that's preventing it being committed. And a 2 means that actually there's a transaction and it's doomed to fail. It's not going to succeed. So it's you need to abort that. You can double check me on that. I'm not 100% sure I've got those numbers the right way around. So double check the documentation. But you can use that exact state to check the status of the transaction. Let's have a look at handling transactions and getting those transactions to make sure my work succeeds or fails as a single unit. So I'm going to, first of all, I'm not using a transaction in this case. I'm going to go and insert into the sales order header table an order, and I'm then going to get the identity of the order that's been inserted, and I'm going to insert some order details to go along with that order here. And if something goes wrong, I'm just simply going to catch the error message and print the error message. So let's go ahead and try to do that. And now my error handler has caught an error, so there isn't an outstanding error in the system because I handled it. And what it's saying is, well, I got an insert statement conflicting because of a foreign key constraint. We've seen this before. And what actually has happened here is I've tried to insert an order detail for a product that doesn't exist. So I get an error there because I've tried to insert for a non-existent product.
But you've also inserted a sales order header.
Indeed. I've managed to insert my sales order header, and I can see the 1 row affected there from that. But I've got a 0 rows affected from the second statement, and it triggered an error which I caught and displayed the message for.
So we have an order with nothing in it.
Yeah. So if I go and have a look, I can actually do a query here that says, find me all of the sales order headers that have no corresponding order details. So I'm using a left outer join to do that. And we talked about left outer joins earlier on in the course. It's a good job we did. So let's go ahead and look at that. And I can actually see, well, here's a sales order header that's the one I inserted, but it doesn't have any order details. So my data is now inconsistent. There's a problem in my database. So I guess the first thing we'll do is we'll go ahead and fix that. So the scope identity will still be valid because I haven't inserted anything else. So I'll go ahead and get rid of that guy. That's deleted that one row. I'll just confirm. Yeah, my data is now consistent. I don't have any order headers that don't have matching order details. And I'll try that again, but this time I'm going to use a transaction. So I'll just hide that result for the moment so we can see the code. Still got the begin try and the end try because I still want to catch any errors that occur. But this time I've got a begin transaction and a commit transaction around in this case, 3 statements that are effectively the atomic unit of work. So I want to insert in the sales order header, I want to get the identity that was inserted, and then I want to insert into the sales order detail, and I want all of that to succeed, or I want all of it to fail. If that succeeds, great. If not, an error occurs, then I'm going to check the transaction count, and if there is a transaction in process, I'm going to print the transaction state. That's just simply so I can see what sort of state the transaction was in. But regardless of that, I'm then going to roll back the transaction. I don't, because this error occurred, I don't want to make this happen. And then I'll print the error message and throw a custom error for good measure, just to indicate that the transaction was cancelled, which is typically what you would do. You would log the error and then throw an error message to the client to say you tried to commit a transaction and it failed. So let's go ahead and run that code. We'll just execute that. And sure enough, I got my one row affected, so it did do the insert of the sales order header.
It's still saying there's one row affected there, though.
Still says there's one row affected. Then it says there's 0 rows affected. So it has, in fact, I mean, it does these operations. It's done them. But then when the error occurred, I get my error thrown. I can see that the transaction state here was 1. So I could add some more complex logic in here to do something based on that. In this case, I haven't bothered. But what I can now do is I'll go and check for my orphaned orders. And even although it said there was one row affected, I don't have any order headers without matching order details, because what happened was it did succeed in that statement, one row was affected, but then it rolled back that transaction. It undid it, if you like, is the point, because it couldn't partially finish the whole transaction.
So if I had a scenario where I've got a large number of records, I've got 10,000 records that I'm updating, and I put it in a transaction, I want it all to happen as a unit of work, they're not one select statement, let's say, so it's multiple things, runs through and does it. And then at the end of it, we do a test on what the values that we've updated are, and we decide, actually, no, they're not valid values. It will have done all the changes, then it will have undone all the changes. So inside a transaction, maybe if we put a test at the beginning to say, oh, what are the values you're passing us for this? And you say, actually, no, those values aren't values we want. You could avoid, because actually what's going to happen is it will do 10,000 updates, and then it will do, because of what's happened, you said 10,000 rollbacks, it actually does do it.
Yes.
And then does undo it. So
yes.
if we could test some logic somewhere, it'd be a good idea if we could test it at the beginning so it didn't do it at all. It's not that it didn't do it, because it actually did do it there and did undo it.
Yes. So if you're implementing your code like this, you would have, if you can do any sort of logical checks before you actually do the updates, you would do those logical tests before you do the updates to save yourself some work. The point of the transaction, though, is that I've tried to do some work that involves multiple statements, and even if the first and second ones succeed, then if any of the subsequent ones fail, I can roll back the whole thing and keep the database consistent. And because it's isolated, remember that ACID, the I is isolated, it won't have affected any other users. They won't have seen, depending on the isolation level I use, they may not have seen that orphaned
but typically,
order header. Typically, they won't see the data that you're inserting. So there is another option. We talked about this issue of using Exacta boards. So I'm just going to use that just to show how that works. We're going to turn it on, and then we're going to do our transaction the same as we did before, exactly the same. This time in the catch block, I'm going to print the error message and throw an error, but I haven't got a rollback statement. I haven't done anything to roll the transaction back explicitly. So let's go ahead and run that. And again, I'll just bring this up so we can see the results of that. Exactly the same as before. 1 row affected for the first statement, 0 rows affected for the order details table. I've got my error message that occurred being printed by my error handler, and then my error handler threw a custom error, which came back to the client application. So it looks at this point, because I didn't have a rollback statement in there, it looks like, well, this might now leave me with inconsistent data. But because I had exact abort on, any error condition will cause any transactions to be rolled back. So even if that error had occurred after all the inserts had failed, and for some reason there was some other error message that came up in the system, then it would have been rolled back. So it's a, like I said when we were looking at the slides, it's an all or nothing solution, but it does mean I didn't have to explicitly write a rollback. Because an error occurred, the system just automatically rolled back the transaction.
But you would tend towards doing it explicitly so we can test what the error was and make sure.
I think you get more control being able to do it explicitly. So if I want to be more sophisticated about how I handle the error and deal with it, then I would use an explicit rollback. If it's a relatively simple example like this, where the only thing that code is doing is inserting a header and inserting a detail, if anything goes wrong, there's a pretty good chance I want to roll back the transaction. So I might want to turn on exact abort that way and just keep it easy. And that takes us to the end of our final module. We've talked a little bit about errors and error messages and the way that those are thrown by the system, or that you can throw yourself. You can raise errors using raise error or throw. We've talked about catching and handling errors using try-catch blocks. And then we talked about transactions to keep your data modifications consistent. Even if you're updating multiple tables or you're doing multiple inserts, making sure they all happen as a unit or they all fail, so that you don't end up with partially committed data. So there's been a lot that we've covered, not just in this module, but in the whole course. We've gone from a very simple, you might remember in the first module, the very first thing we did was select star from product. And that was where we started, with that one line of Transact SQL code. And we've now looked at all of the different ways that we can select data from tables. We can join multiple tables together. We can union tables. We can filter the data that's coming out. We can use aggregates, and we can use groupings to group the results that come out, to summarize them. We can pivot data and unpivot data as it comes out. We've looked at being able to insert and update and delete data in tables. We've looked at using subqueries, queries within queries. We've looked at using error handling and transactions in this final module, and we looked previously at writing procedural code in Transact SQL, where you're using ifs and while loops and all those types of things. It's a really powerful language, Transact SQL, within the SQL Server or within your Azure SQL database environment, where you can implement pretty complicated, sophisticated solutions. And by now, with the things you've learned in this course and what you've had to go at in the labs, you should now be able to write some pretty sophisticated Transact SQL code of your own and write some pretty compelling database solutions. I hope you've enjoyed the course. We've certainly enjoyed delivering it. Please do the final lab. I hope you've been doing the labs as we've gone through, and you've got your chance to get your hands on and use this for yourself. The final lab is on error handling and transactions, and we'll challenge you to have a go at that and start to build those kind of more robust solutions that keep your data integrity intact. And I hope you'll come back and join us again for more training on other aspects of using databases and other Microsoft technologies. It just remains for me to say to Jeff, thanks very much for joining me in this course and helping me through.
Thank you. It's been great fun, I think, going through this quite nicely encapsulating all this code that we're doing here.
Yeah, it's been a pretty good little coverage. So thanks to Jeff, and goodbye from both of us, and we'll see you back again.